All right, guys, so introducing the concept of integration. Okay, the entire concept of integration is dealing with area under a curve. Now, just like the derivative dealt with the slope of a tangent line, and that slope could represent numerous other things depending on the context, here, area under a curve can represent numerous other things depending on the context, okay? For example, if our function represents the velocity, then when you find the area under that velocity function, you actually find a distance traveled, okay? And you're like, how in the world does area give us a distance? We'll learn about that, okay? What I want you to do today, though, through this activity, is to get a good idea of what's going on and get the whole concept of area under a curve. And it's also going to introduce kind of the background to integration by breaking up area under a curve into little pieces, okay? And it's really the basis of what we call in calculus Riemann sums, which are not part of the SL. We'll probably be thankful for that. But the Riemann sums are something that are really the backbone of the integral. We're just going to jump straight to using the integral on kind of a basic level here. So you have some directions here. This is an introduction to areas bounded by functions in the x-axis on a given interval. Since the functions in the beginning of the lesson are linear or piecewise linear, the enclosed regions form rectangles, triangles, or trapezoids. Okay, so we have the formulas here in case you've forgotten those, which hopefully you haven't. Within the lesson, the concept of accumulation is extended to approximating areas enclosed by nonlinear functions and the x-axis on a given interval using rectangles and trapezoids. So that's where we're going with this, guys. So you have some formulas here, and then you have several problems. These should not, especially these first ones, should not take very long, okay? But I want you to get some practice with them, and then it kind of builds. You have some piecewise functions to work with that you can see here. Notice it gives you an interval, okay? So only find the area in that interval. Like here it's from 0 to 5 for part E in this case. And then it builds and says approximating area using left or right hand sums. And that's where those sums are actually what we call Riemann sums. And that's kind of what will lead us up into what we're doing tomorrow in working with integration more specifically, okay? And then it gives us a couple of examples to work through there, okay? So I'm going to have you guys break up into groups of either 2 or 3. I want you to work on this together and kind of get the foundation here of what we're going to be studying, okay?